Look at this realistic 3D render of a standard Ugandan brick house. It gives you a great sense of the final product. But if you handed an artistic sketch of this design to a foreman on a construction site, they couldn't actually build it. A sketch captures a mood, but it lacks exact mathematical data. The contractor needs to know the exact thickness of the load-bearing walls, the precise depth of the foundation, and the literal boundaries of the property line. A beautiful picture cannot answer those questions. To solve this, we use building drawing. This is a highly specialized, standardized visual language used to mathematically flatten a complex three-dimensional structure into precise two-dimensional instructions. Mastering this technical language is required to pass your Senior 3 NCDC exams, but out in the field, it is a non-negotiable legal and safety standard. If the math is wrong, the roof collapses. The entire purpose of a blueprint is to eliminate human interpretation. It provides a strict set of geometric rules that forces the construction crew to execute the architect's exact physical vision. The first step in deconstructing a building is separating that single 3D structure into distinct isolated flat viewpoints. We start with the most zoomed-out perspective. This top-down view is the site plan. It maps the macroscopic layout, showing property lines and access roads. For your exams, you must always include a clearly labeled north point, which orientates the entire property to magnetic north. Next, we move to elevations. By stripping away all 3D perspective, we get orthographic views that show the completely flat exterior faces of the building, the true front, back, and sides. To see inside, we use a floor plan. This is a horizontal section view. We are slicing the top off the building to reveal the internal layout of rooms, wall thicknesses, and exact positions of doors and windows from above. Finally, sectional views require a vertical cut straight down through the building. This exposes the hidden internal anatomy, detailing exactly how deep the foundation sits in the soil and how the roof trusses attach to the frame. By combining these distinct horizontal and vertical slices, the architect creates a complete spatial map. There are no blind spots, leaving zero guesswork for the contractor on site. Once the space is mapped, we zoom into the microscopic geometry of the lines themselves. In technical drawing, a line's thickness is a strict command, not an artistic choice. Because a real building cannot fit on a desk, we use scale to shrink the dimensions proportionately. The standard NCDC ratios are 1:50 for detailed floor plans and sections, and 1:100 for the larger site plans. Look closely at this floor plan layout. Notice how the external wall lines pulse with a heavy, thick line weight. Thick lines are strictly reserved for materials that have been actively cut by your horizontal or vertical section plane. For exam purposes, standard brickwork external walls are typically drawn to represent exactly 200 millimeters in thickness. In contrast, thin lines are used for everything that is not cut by the section plane. This includes background projections, dimension lines, furniture, and material patterns. Adhering perfectly to these line weights gives a flat, two-dimensional technical drawing its true sense of physical depth. It instantly tells the builder which part of the drawing is a solid, load-bearing wall and which part is empty space. To populate that space efficiently, architects use symbols. These standardized shapes act as a universal vocabulary, allowing complex 3D objects to be drawn quickly and legibly. The basic rule for any opening, like a door or a window, is that it must be drawn as a distinct, clear gap within the thick wall lines. This diagram shows the layout for a double swing door. You must draw two distinct lines for the door leaves meeting in the center, and two separate swing arcs to indicate exactly how each door moves independently. Staircases require a series of clean, parallel lines for the individual steps. Crucially, they strictly require a bold arrow indicating the upward or downward direction of travel from that floor level. In section views, we use hatching, specific angled line patterns, to dictate materials. This diagram shows cross-hatching for concrete, diagonal lines for brickwork, and the standard earth pattern for soil. Using the wrong symbol or hatching pattern can result in massive failures on site. If you draw the wrong diagonal lines, a contractor might pour heavy concrete exactly where you intended to have lightweight brick. Text formatting has its own strict rules. All lettering must be neat, technical, and exclusively uppercase. This guarantees maximum legibility when a builder is reading a faded printout in the sun. For dimensioning, all numbers and measurement lines must be placed entirely outside the main outline of the building. Placing text inside the rooms creates visual clutter and makes the plan unreadable. Clear, standardized annotation acts as the final safeguard against costly, irreversible errors on a loud and chaotic construction site. Watch how these distinct, transparent layers come together. Combine the spatial views, precise line weights, standard symbols, and clean annotations, and they stack together to form a flawless, professional blueprint. Consistency and strict standardization are the only things separating an amateur's imagination from a contractor's physical reality. Adhering to these NCDC standards is exactly how you pass your O-level examinations. More importantly, it lays the technical foundation required for a real career in engineering or architecture. To master these drafting techniques and access more Senior 3 class videos, check out the full syllabus and educational resources at www.yaka.cc.